So here is a curve given. You might recognize it as the equation of a circle with radius 5 and the center at the origin, or you may not. And I need to find the equation of the tangent and normal lines at the point 3, -4. Well, what do we know about derivative? Derivative is the same as the slope of the tangent, which is the same as the rate of change. And they asked me for the equation of the tangent line, so I know I'm going to need the slope of the tangent line because I'm going to use my form of the linear equation y minus y1 is equal to m, the slope, times x minus x1. Fortunately, they gave me my y1 and my x1 right there, but I still don't know the slope of the tangent. In order to find the slope of the tangent, I need to find the derivative of this curve. So here's what I'm going to do. I might write it like this. I might say I need that prime and I need that prime. But it's the same thing as if I put the dy over dx in front of it. So let's look at the first part of it here. Well, the derivative of this, it's to the, so I have the derivative of x squared is 2x, plus the derivative of y squared is 2y times dy dx. Remember, because y is a function, and I'm using the chain rule right here. I'm saying, well, I need the derivative of the outside function, which is y, times the derivative of the inside function. I don't know what it is yet, but it has to be with respect to x. And I take the derivative of 25, and that's equal to 0. So if I'm trying to find dy to dx, the derivative of this curve, I need to get that all by itself on one side. So I know 2y dy dx is equal to negative 2x. I subtracted 2x from both sides. And now I'm going to do the clever thing of dividing both sides by 2y. So that cancels out, and I find out that dy dx is equal to, well, those negative 2's cancel out. No, I just divided it by 2y. I didn't divide it by negative 2y. I'm sorry. I is equal to negative x divided by y. So this is the slope of my tangent line at any particular point. Well, I have a point. The point I'm looking for is the point 3, -4. So the slope at that point is going to be equal to -3 divided by -4. In other words, the slope right there is going to be equal to 3/4. This really should be m. The slope right there at point P, m at point P is equal to 3/4. Again, my point there is 3, -4. So the equation of the tangent line is going to be equal to y minus -4 is equal to 3/4 x minus 3. And we can change this to be y plus 4. And that should be the tangent line right there. So I'm going to use Desmos to graph this because graphing a circle in TI calculator is designed to graph functions, and a circle, as you know, is not a function. It doesn't pass the vertical line test. But Desmos will graph it, so let me call it up. So I put my two equations into Desmos, and I would say it's looking pretty good. Looking like I have the tangent line right there. One of the nice things about Desmos is that you can just kind of type in equations and it's going to graph it. You don't have to put it in point-slope form or slope-intercept form or anything like that. Almost any form, and it's going to graph it. So that's the equation of the tangent line. I'm pretty comfortable with that. To find the equation of the normal line, it's just going to be, the slope is going to be the negative reciprocal. So, and I'm going to have the same point for negative 3. So my normal line is going to be y plus 4 is equal to negative 4/3, a negative reciprocal, x minus 3. Let's see if it works. Yep, I think it looks pretty good. I think I have a couple perpendicular lines, I have the tangent, I have the normal. I'm pretty happy with this solution.